All right. Hello, everyone. Thank you so much for joining our introduction to crane manufacturing webinar. My name is Emily Rossbro. I'm part of the marketing team here at ACE, and I'll start with a quick overview of who we are and where our manufacturing takes place before introducing today's presenter, Andy Gurley. Ace Industries has been family owned and operated since 1932 when it began as a small electric motor shop in Atlanta, Georgia. That man that started the motor shop was my great grandfather, and I think he would be so proud to see not only how Ace has grown, but how our Ace family has grown as well. Over the years, we've grown into one of the largest independent overhead and crane and hoist companies in the country, with operations spanning distribution, service, and manufacturing. In our 9 decades as a company, we have had quite a few standout moments, some of which include beginning manufacturing bridge cranes in 1983, as you can see on our timeline. The company moved to our third generation owners in 2004, and in 2018 and 2025, we had two members of our ACE family nominated as the president of the CMAA, the Construction Management Association of America. That was Josh Arwood, our CEO, in 2018, and Molly Wood, our senior engineer, in 2025. She is also set to be president in 2026, which is very exciting, and we are super proud of her. We have fully stocked warehouses, service branches, and manufacturing facilities across the US, all working together to support our customers' lifting needs. Our two main manufacturing facilities are located in Brazelton, Georgia, and in Cleveland, Texas, where our teams design and build custom cranes and engineered lifting products from the ground up. These shops handle everything from fabrication and assembly to final testing, a process you will learn a lot about today. During the presentation, we would like you to feel free to type your questions in the chat of the Q&A at the top of your screen. And he'll be answering questions as they come along, so feel free to ask them as you have them. And now, before we get started, I would like to take a moment to introduce Andy Gurley, your presenter. He is our Director of Manufacturing, and he has been in the crane industry for over 25 years, starting his career in 1997 and joining ACE in 2000. He's worked across multiple sides of the business, from national sales to business development, and now leads our manufacturing division. That experience gives him a unique, full picture understanding of how design decisions, customer needs, and fabrication all come together to build cranes that last. Putting this webinar together was no small feat, mostly because Andy's knowledge of crane manufacturing is so robust that, as he likes to say, it's easy to fall down a few rabbit holes once you get into the details. But today we have a presentation that gets down to the foundation of manufacturing a crane, from questions to ask when first designing to a step-by-step process of putting the crane together. We hope you can leave this webinar with a new understanding and appreciation for what goes into the crane manufacturing process. With that, I'm excited to hand things over to Andy to guide us through the rabbit hole. Andy, you're muted.
Well, there you go. Wrong one. Okay, did everyone see my screen? Everybody good to go, correct? That would be a yes. I'm taking it. Okay. All right. So a little bit of run into crane manufacturing. It's the rabbit hole she mentioned. It's a long, deep rabbit hole. So we're going to try to stay on the surface here and give you guys some good stuff and some thoughts and a little bit of maybe hopefully some knowledge to walk away with as we go through this. So we're going to talk a little bit about what happens with the crane manufacturing. We're going to talk some basics, cranes and equipment, under running, top running, monorails, jibs, workstations, major components, and then discuss runway options, what types of runways there are, what types of runways, how we support the runways, and then why you'd want a certain type of runway or not. And lastly, we're going to look at engineering a crane, a little bit about layout, squaring, how we fabricate a box girder, and how we finish up a crane with, of course, with wiring and paint, testing, Q&A, etc. All right, crane and hoist basics. Let me move my little deal over here a little bit. I can't. Okay, crane and hoist basics. Here we go. All right, so there's several different kinds of cranes. We're going to start with top running double girder cranes, and I'll get into this more as we go. We got cranes, top running single girder cranes, which you can see this is a single box girder. On this crane, the hoist runs underneath the crane, underneath the box. On this one, you see it running on top of the girder. It's a top running double girder crane. You can see the trolley up here on top of the girders. The little, you can see the lower block right there. And you see it, obviously see two girders here. On this one on the right, you can see that this is an underrunning crane because the runway is right there. It's hanging below that. And this is a single girder underrunning crane. You can see the hoist is underrunning. A lot in my time, people confuse underrunning cranes with underrunning hoists. And this is an underrunning crane. The hoist is underrunning as well. So just know that top running crane with underrunning hoist, top running crane with a top running trolley. Okay. All right, next we'll start with the double girder cranes. Here's some examples. You can see the hoist here on top of the girders. You can see there's two girders. See the festooning running across here. That's for power and control. And you see the end trucks running on top of the crane, the runway there. This is obviously a freestanding runway outside of some type of steel handling facility. So if you guys got any questions, I'm not seeing the Q&A, Em, so if you get one, let me know, okay?
I will let you know.
Okay, single girder cranes, again, there's some examples here. This is the underrunning crane we discussed a minute ago. Underrunning single girder. This is the top running single girder. In a little while, I'm going to talk about what we're lifting and what we're using to lift. You can see the swing set up here. This looks like maybe a dam operation because they're lifting some kind of a door there or something. It looks like it's got some slots in it. So what you're lifting and how you're lifting it is a big conversation with the crane. Then over here on the left, you can see the bridge crane. It's a top running single girder on top of the runway. And you see this is sort of a freestanding runway. You can see we design H columns for some runways. And you can see this is a freestanding runway because you see the moment columns there. And we'll get to that in a second as well. Lastly, we've got jib cranes, workstation cranes, and monorails. Jib cranes are a good application. The only problem with them is you got to put a big footer in the ground, and they're not easily moved after you put that big footer in the ground, obviously. This is a workstation crane. This is typically a freestanding, underrunning crane and runway. So you can see, barely see here, hopefully the bridge crane's right there. The runway's hanging below the headers. This is the header on the freestanding system. These typically go up to about 2 tons, something like that. And on the right here, that's our illustrious president standing right there. I got to point that out from days gone by. This is a 15-ton monorail we put in a facility outside of Atlanta years ago. It's a semi-freestanding monorail system. Okay, so now let's get into some crux of this thing. We want to talk about what do we need to know? We need to know the voltage that you're going to be operating on. That sets up a lot as far as what we can do and the cost associated with it. So we need to know the voltage. We need to know what you're trying to pick up. And the reason we want to know that is we're trying to figure out what your capacity is. So if you pick up 10 tons, then we need to know it. If you pick up 5, then we need to know it. If you pick up 2, we need to know that. And lastly, on this one, we need to talk about what is your desired hook height. That sets up a tremendous amount of conversation because you might not have enough room to make the kind of lift you're trying to make and with whatever kind of lifting apparatus you're using. So we need to know how high your hook needs to be, what your desired hook height is. Okay. All right. Next, we're going to ask some more questions. I can't seem to move this over here. Let's see what we got going on here. There we go. Okay. So we're going to ask you, how are you going to lift it? A minute ago, I pointed out a sling. We're going to use, to lift your object, we're going to use slings. We're going to use a lifting beam. We're going to use a magnet. What are we going to use to pick up your object? What is the length, width, height, and weight of the object? That makes a big difference on how you're going to pick it up, as well as how we're going to set you up to design a crane that'll actually operate well in your whatever your requirements are. And then lastly, we need to know a little bit about how high do you want to lift it. A truck is typically a flatbed truck, 48 inches tall. So if you're going to set stuff on the back of a truck, you're going to have to lift it 48 inches. Then we're going to have to include the sling in that 48 inches. We're going to have to include the lifting beam in that 48 inches, or the magnet, or whatever it is you're using in that elevation. So if you've got a roof that's low and you're trying to pick up something that's going to be really tall, it's going to be tough to do sometimes. So we need to know what you're picking up, what you're doing with it, and how high you want to pick it up, just as a starter. Okay, we also need to know to set up our cycles and your class of crane is how many picks you make an hour and what are the weights. We already talked about how heavy is the object. So if you're going to pick up something once a shift or twice a shift and it weighs a lot, that is easy to solve the problem. If you're going to pick up something that weighs a tremendous amount of weight and you're going to pick it up very often, let's say 10 or 15 times every shift, every hour, that sets you up for a whole different game. So we're talking about class of cranes, A, B, C, D, E, or F. A being the least duty crane, going to F being the heaviest duty crane. All right, and then all in between. So another question we have to have are their operating conditions. So once we determine the cycle and the class of your crane, we need to know what you're going to do with it. We operating outside, or we operating hot, cold, wet, dusty, or corrosive, such as any kind of acid-based area, or any type of any kind of acid, any kind of corrosive material, or battery acid, for example. That's always bad. And then lastly, is it a hazardous area? Is it explosive? And we have to, I just got a question here. Wow. Okay. Somebody just asked how deep the jib crane footing is typical. That's a good question because it depends on the capacity of the jib and the boom length. So I would say typically if you've got a 10-foot boom and you're 3 or 4 tons, your footer is going to be 6 by 4 by 6 by 6 by 4 foot deep, something like that. If you're going to go out 5 tons and 20 feet, it's going to be as big as your pickup truck. So that's a good question, but difficult to answer. Okay, so lastly, if we got a hazardous area, we need to know the hazard, and this will be a class and division. This will be a C1, D1, and grouping. And you guys that work in plants know that the answer to that question if you've got a hazardous area. So we need to know the class, division, and group for the hazard so we can design the electrical system to handle whatever the hazard is. Okay, the last things we like to ask are what kind of speeds do you want in the hoist, trolley, and the bridge? And these are important questions because some cranes, single girder cranes especially, aren't designed to run really, really fast. So if you want to go fast, you're going to have to go to a double girder crane typically, and that would be something over 200 feet per minute, that type of speed. Typically, we build cranes to about 100 feet a minute. That's walking speed, and it's kind of comfortable to operate the crane at that speed. So if you've got a short runway, you really don't need to go really, really fast. If you've got a really long runway, then you may need to move a little quicker if you're traveling back and forth on the same runway, back and forth, back and forth. So, all right, a little major component conversation. Here's the hoist. This is a single trolley dual hoist system. People do this to have a smaller capacity hoist on one side of the trolley and larger on the other side. They sometimes want it because the smaller hoist is faster, or they want it because they're making tandem picks with some kind of object they're trying to pick up together. So that's a single trolley, top running with dual hoist on it. Here's your bridge drive. This would be the shaft. This is the motor and reducer here for the bridge drives. There's one on each side. That's called A4 is the world we live in now. We don't do the single shaft too much anymore, which that was the old days. Here is the control panel. Let me erase that off there. There you go. Here's the control panel. Then we have the push button station hanging down. We'd be more than happy to put a radio on there for you if you want it. Here's the lower hook block assembly. We have the end truck here, the bridge bumpers that keep you from banging into stuff. and damaging the crane. And we have the rail for the top running trolley on both sides. We have the festoon system. You can see it hanging down right there. This crane has a walkway on it. And lastly, we see you got the rail sweeps, which everybody always asks for rail sweeps and specs, but they pretty much come standard nowadays. So that's kind of the major components of a crane in a nutshell. Okay, talk about runways for a minute. I'm not getting any questions here. Your eyes must be absorbing everything pretty well. Okay, first question obviously is, do you need a runway, or do you have an existing runway? What type of runway do you need for the application? Is it top running, under running, or do you need a monorail for what we're doing here? And then the other question we always ask is it a new building or an existing building? Is it a brand new building? That changes the scope a little bit. If it's an existing building, that's a different kind of runway application. If it's a new runway, we can do it haunch mounted, ceiling mounted, or totally freestanding runway. If it's haunch mounted, we need to know what column spacing we're going to be operating on and who's supplying the haunches. So if it's a new building, typically the building manufacturer, the PEMB, will supply the haunches and maybe even the runway. But if not, we can design the haunches and put them in if there's none there. And lastly, do you have any building drawings? Because building drawings are always handy for us to help with our engineering. If the runway is going to be ceiling mounted, which would be an underrunning crane, what structure will the runway be suspended from, and on what spacing? I've seen it where they try to hang them from web to joist to all kinds of crazy stuff. So a ceiling mounted runway for a building that's not designed for it creates a lot of issues, to say the least. I got another question here that's come in. Oh, let's see here. So since when designing a 4-wheel or 8-wheel crane, is it best to have a 2-wheel drive or 4-wheel drive? That's a good question. So typically a 4-wheel crane would be 2 wheels on each side of the crane. This would be a 2-wheel crane, I mean 1 wheel there and 1 wheel there. And you see the drives are on one side of this. On a bogie crane, which would be 8-wheel crane, I have a picture later on of it. I can show you here. Hold on one second and get back to this. Let me erase this picture. I'll erase all that junk. Sorry. Okay, so you can see here on this one, you can see the bogie end trucks right here. And they typically come with drives on each one of those end trucks. So you can do that as well. But they not always, so it depends on the crane. So many times you'll have a single drive and a single drive on the other side on one wheel, and other times we can have 4-wheel drive. So, but that is an 8-wheel end truck right there, 8 wheels. It's called a bogie. Okay. It's a good question right there, though. But you don't, I can't really tell you the difference between 2-wheel drive and a 4-wheel drive and line out any kind of big difference between them. I don't know if I can really say that with any logic, honestly. I think it would depend on the speed of the crane and also what class of crane it was. And you'd have to go between 2-wheel drive and 4-wheel drive. That would probably be my answer at this point. Okay. So we're back into runways here. We already went through this. Let me find where I was here. Okay. Ceiling mounted, we talked about that, and that would be an underrunning crane if it's ceiling mounted. So the first type of freestanding crane system is called an A-frame. And you can see it looks like an A. You've got the main column here, and you've got what we call a kicker leg out here. This is typically used outside. You can see on the picture I showed you a minute ago with the steel handling place. This was used outside. It takes less of a concrete footer, but it's not typically used inside because it's a larger footprint. When you're paying for a building, you really don't want to eat up square footage with this space between the kicker and the leg, which may very well be 4 or 5 feet. It could be out to 12, 15 feet, depending on the capacity of the crane and the elevation of this runway. So this is an A-frame, typically used outside. Inside, we do a lot of moment column design, The way we design this is it has an I-beam with a T-beam welded into the I-beam, so it takes all the reactions longitudinal as well as laterally. I got another question here. It's the same question. Is it possible the crane will skew or crab walk when using four-wheel drive crane? Do the drives stay synced up? The drives would be operating off the same drive, I would imagine. So if you do have that and the bridge is square, you're not going to have any crabbing. And if your runway is straight too, you have to have a straight runway as well. So good question. Okay, so moment column here takes up minimal floor space. You can see the base plate area there, and also you see the footer. And these things require pretty good size footer. Sorry about that. So they require a large footer, and the taller it is, the bigger the footer. And I can't tell you the size of the footers, but for a 10-ton crane, maybe 60 feet wide, a footer would be, say, 18, 20 inches deep and 4x6 or something like that. And obviously, the higher and the larger capacity, the bigger the footer gets, because all the forces are taken in right here. There's no bracing, there's no nothing else. That takes all the forces of the crane. Just a header brace system. These are typically for lower capacity cranes as well as shorter runways, lower capacity being 15 tons and down. Here's the header. You can see it there. Here's your runway beam, the rails on top of that. And notice we put some knee braces in there to help with longitudinal forces. So the header's tied off laterally and the knee braces take it longitudinally. Okay. Another type of column we use is a sister column. Sorry, this picture's not bigger, but you can see the column here. We tie it back to the building column in your building. It typically has a smaller concrete footer, and your building has to be designed to withstand the loads of the crane. So if you're in an existing building, you're going to have to hire a PE to come in and assess the building and see if it will support the loadings of the crane and runway. Not many times buildings are built to hold a crane. So if you got an old building and it wasn't designed for this, you're going to have to maybe put some material in your columns to support it, but you got to get a PE to tell us it's okay to tie it back to the building. If not, we go back to the old moment column there and be done with it, right? Okay. The next one is a secondary column. This would be in the middle of your building. It goes from the floor to the top of your joist in your ceiling. We tie it off that way. This is another building, has to be designed or structurally built to be able to support the crane loadings. So this would require PE again. This is not a very common runway type of runway. You don't see it very often. Okay, talking a little bit about haunches here. So on this picture here, you can see the haunch is right here. Okay, I got another question. It says, do you work with building manufacturers? Yes, all the time. The answer is yes, all the time. You can see the haunch there. You see the runway beam sitting on it on both sides, and you can even maybe see the rail right there on top of that. I don't know if you can see that as well. So that's a haunch, typical haunch in a building, a prefab building, if you want to say that. This is a same picture here. The guys are putting in a runway beam on the existing haunches in the building. This particular building was designed with haunches, and we came in behind them and put the runway beams in it. I would say most of the time you can get it cheaper if you go through your building guy. The manufacturer building guy can include the beams as well as the haunches. And when you install your building, we'll come in behind you and we'll put in the runway rail and conductor bar. It's more expensive for us to put the beams in than the PEMB guy. Okay, so under running runway, you can see here again, we showed you a workstation a minute ago. This is the header. You can see the beam ties off to the header. That's pretty basically all there is to under running runway. If it's unlevel, or if your ceiling is unlevel, we may have to use some tie rods to hang it down like this to make sure that we keep the thing level. If we do that, we got to tie it back to the building. Okay. So long story short, under running runways, we need to know what we're hanging it from, as well as if the building is level, are we going to bolt it straight up to as this one here shows, it's direct bolt. You can see that's directly bolted to the header, or we're going to use hangers to hang the system down. We'd hang it like that and put a beam right there like that. Okay. So underrunning runway, typical for ceiling mounted cranes used in aircraft industry, that kind of stuff. So another type of underrunning runway would be patented track. It's been around for decades. Patented track is typically 2, 3 1/4, 4-inch lower flange. It's used for underrunning bridge cranes and curved monorail systems. It was put together back in the day because you could put so much more weight on this than you can on an I-beam. So a patented track typically carries a tremendous amount more weight than I-beam systems, and also you can go to heavier capacities and faster. Okay, and it's just more durable. I mean, if you're gonna, there's systems that I've seen that have been in business been up there for 80, 90 years, been up there forever, and still working fine. So the durability of patented track is there, but also the price is there as well. Okay, if we're doing a freestanding system, we got more questions here. What is the depth of your concrete? And I hate to keep bringing up concrete, but it is truly the difficulty of any kind of crane system. Is how deep's your concrete? What's your desired spacing of your columns for your freestanding system? And then how long does it need to be? This helps us out because if it's going to be really long and freestanding, we may need to put additional X bracing in or some struts or something somewhere on the runway to help the longitudinal forces out. Again, you can't really see this well, but there's a typical footer right there for a mullet column. Here's a typical base plate. And this is a anchor bolt, just kind of a designed anchor bolt to show you a little bit about anchors. So most of the time, if we do a footer, your concrete guy will come in and he'll put the anchor bolts in there for us. Then all we do is come in and set the column on top of his anchor bolts. Okay. More questions. How many cranes are going to be in each bay between the columns, right? We need to know how much weight the runway needs to hold up. So if you're going to put 2 5-ton cranes in the same bay at the same time, we need to make a 10-ton runway. We do have ways we can keep the cranes out of the bay at the same time. But if you need to make a pick where both cranes need to be next to each other, we need to increase the capacity of the runway to match whatever the capacity of the cranes are. We also want to know how many cranes are on the runway. If this is existing, we want to know how many cranes are on the runway now. And do we need to put any anti-collision on there? Or what do we need to do as far as protecting ourselves from the other cranes? And also, we showed a bumper a little while ago. When there's other cranes on the runway, we need to match our bumper to the elevation of the other cranes. So when they hit each other, they don't do any damage. So the bumpers match. Another reason we have to know what's on the runway. And lastly, if you've got a runway that has like a 50-ton crane on it, and you want to put a 10-ton crane on it as a helper, we need to know the rail size because the 50-ton crane is going to have 80 or 100-pound rail on it. And the 10-ton crane is not designed to run on that size of rail. It's designed to run on 30 or 40-pound rail. So we'll have to quote and design it with an end truck that has a wheel big enough to run on the rail that the 50-ton crane runs on. So we need to know what's the existing rail size if we're going into a building that is there, right? Okay, other questions. We need to know how high the rail is. What's the top of the rail on the existing runway? We want to know that so we'll know how much lift to put on the hoist. What is the available height over the rail? We need to know that so we see if we can fit it into the space available. So if you've got 3 or 4 feet available over the top of the rail to the lowest obstruction, or are you talking about 10 feet or 12 feet? I have another question here. I have a 1,500-foot runway, outdoor craneway, 100-foot span with 2 15-ton double girder dual hoist and 1 20-ton double girder dual hoist. Having trouble with bridge rail getting gaps in the rail sections. What are your thoughts on getting it welded to be a solid 1,500 bridge located in Illinois? If you're having problems, I would ask, first of all, do you have hook bolts or do you have welded, like Gantrex clips, welded clips holding your rail down? If you're getting gaps, something's going on with your runway or something's going on with your rail. So something's moving, obviously, right? So I've seen welded rail a couple of times in places that do a lot of steel handling. Obviously, you're moving a lot of steel here, I would guess. So you might try to look and see what's going on with your runway. Maybe your tiebacks on your runway are not sufficient, and your runway beams are moving further than they should be, like this. So that would be the first thing I do. Maybe get a runway survey and find out what's going on with your runway. And it's going to 1,500-foot runway's big one. So that's what I would do first. Get a runway survey, check your rail, see where it's loose. I would have somebody check that, make sure if you've got, like I say, clips or hook bolts, you can have that checked. There, I would say they're getting loose. If you're moving that much, I would guess your rail's getting loose on your runway. First thing I would do is those two things, and then I'd start talking about welding the sections. All right, that's a good question. So that's a good one. Okay, we're going to get the height over the top of the rail because we need to know we can fit the crane in there if it's inside a building. And lastly, back around the early 2000s, they passed a rule that said you had to have a fourth bar on your runways, would be a ground. So you don't have to do that as a business owner or building owner. It's your decision. But we have to offer the fourth ground bar. So nowadays the cranes are grounded through that bar into the power, into the building into the building ground. In the old days, the crane grounded through the rail, into the columns, and into the ground that way. They didn't really have a ground. So they created that, and that's why we have to ask if you've got a fourth bar on your runway now. If you don't, we need to offer to install one. Okay. Next, we're looking at engineering a crane. A little bit into this. This is the rabbit hole here. I got another question. This guy's asking, or person's asking, what duty rating should an outdoor limited use overhead bridge crane rated for 150 tons be recommended? I would just say if you're going to use limited use, it'll be a Class C or Class D crane, either one of those. It won't matter about the capacity. It'd be a Class C or Class D. Limited use being once or twice a day, you're going to lift capacity. They would be Class C or probably be Class D. Nobody's going to make a 150-ton Class C crane. So you'd be Class D in trucks, Class D or H4 duty hoist on that question. Another good question. Okay, a little bit about engineering here. We're going to talk about how we go through the process of building a crane. So we're going to talk, the engineering department obviously provides us a fab package that we give to the shop so they know the hole size. That gives them the welding thickness, stitch welding, complete welding, tells them also what beams, how to cut the beams, et cetera, et cetera. So the fab package is pretty important here. Then we're going to talk a little bit about laying out the end trucks and squaring it. We're going to show you what we do to fabricate a box. And then lastly, we're going to show you how we fit up a girder, weld it out, and then obviously final finishing, painting, wiring, and testing the crane. Okay, first thing we'd like to do is verify the end truck model, the detailed drawings. We got a lot of end trucks stacked up there, so we want the guys to make sure they get the right set of end trucks. Measure and mark the center lines on the end truck, and we set the squaring points. So the squaring points are usually on top of each wheel, and we mark where we're going to set the crane on the end truck. All right. We have pedestals, and you can see this is the pedestal right here. We have elevation bolts right there. So the first thing we do is we set it on there and we get everything level. So we use the leveling bolts to get the end trucks level. Then we're going to pull the span. You can see right here, he's got his scale in his hand. He puts tension on the tape so we know we don't have any slack in the tape. Pulls it, and we mark the span right there. Boom, to get it, start getting it square, okay? Then we go and we do the old Pythagorean theorem, a squared plus b squared equals c squared, to confirm that we're square between our points. So the goal, obviously, to get the truck span and squared so we're ready to put the crane on there when we get the girder ready, okay? All right. Next, I'm going to show you a little bit about how we set up and do a box girder crane. So this is our jig, and laying here are two flanges, and the flanges are the top and bottom of the bridge girder. So we take that, then we get the web of the bridge girder, which is this, lay it down on the jig. We set the flange next to the bridge girder, next to the flange, next to the web. I'm getting tongue tied here. and we start welding. So we use the submerged arc welder to weld that down on both sides. That starts the bridge box girder. So the flange is on, the web is on, and then the next picture here shows you the diaphragms and the stiffeners. We weld those in as well. That's getting ready. So one side's on, one top flange is on, the diaphragms are in, the stiffeners are in, and then we go to the finished product. You can see this has the top web laying on it, the bottom web's welded on it, and it's still missing the lower flange on the crane. I know this is the lower flange because that's where the intrust's going to sit right there. And then here you can see that we've welded the lower flange on this one. Again, you can see the intrust seat right there. And here's our submerged arc welder. We use that because it creates a hotter weld on the joint using the flux. Flux goes on top of the weld, and that makes it hotter, stays hotter longer, so you get a better weld. Here it is finished again, just another picture. I kind of want to show you this is real pretty and straight. And again, there's our submerged arc welder. All right, next, after we build the box, we take it. Now this is already painted over here, but we take it, we go to the end truck, we mark and match the trolley gauge. If it's a double girder, we match the trolley gauge on the end truck to make sure we're going to have our gauge right to fit our trolley. Then we set the girders unpainted to get them plumb and level, so we have all four wheels touching the rail on top of the girder. So I've seen a lot in my career where one wheel on a four-wheel trolley on a top running train, one wheel does not touch. And I've also seen an underrunning cranes, and that comes from either some twist, sweep, maybe cambers out, a lot of reasons why it won't happen, or maybe it just wasn't built correctly in the first place. So we check this to make sure we're level and plumb all the way down. We match drill the connection plates of the end trucks, which is, I got another question, which, let's see, all right, so we match drill connection plates to the end trucks. And you can see right here, this is fitted, but the match plate goes on top of the end truck. And then we weld the girder connections to the girder plates. Golly, I'm getting sloppy with my pen here, sorry. We weld the girder connections to the girder plates. And at that time, we drill holes for the bolts. We bolt double girder cranes together all the time. We never do weld those together. So we drill the holes, and then once we set it in there, we put our bolts in there and we tie it down. And that's the end of our process here as far as setting the girder on the end truck. The question is, when designing and fabricating box girders, should an inside diaphragm baffle be continuously welded, or is it okay to have them stitch welded? That's a great question. Engineering specifies how much weld and to put down on anything. So engineering tells us to stitch weld them, or they tell us to weld it. They'll say we want a 4-inch stitch or a 6-inch stitch or a 2-foot stitch, whatever it is. So they'll engineering lays that out in the fab package they deliver to the shop. So it's a good question, but you don't have to continuously weld them unless engineering says so. Oh, another question here. What determines the size of the end trucks? The span of the crane determines the wheelbase of the end truck. So if we go back to, if we look here, I don't have the span here, but the span, the wheelbase would be the distance between this wheel and this wheel. And depending on the double girder or single girder crane, it's either 700 or 600 or 700 one. So you have a, if you have a 60-foot span crane, you'll have maybe a 7-foot 6-inch wheelbase, something like that. But for a double girder crane, it'll be longer than that because you got two girders. For a single girder crane, it may be a little shorter and the wheelbase will be a little shorter. But determining the size of the end trucks is the span of the crane. Good question. That's a great question. Okay, where was that here? Okay, we're gonna fit and weld our festoon brackets on before we paint it. There's you can see the bracket right there, and you can see the festoon, C-track festooning, right? You see the C-track there anyway. So we weld the brackets on to mount the C-track. The C-track goes on after we paint it. And then we also check our rail gauge. Again, we're going to make sure we're within 1/8 tolerance, which is what's required. All right. Okay, so after we've done what we've done here, after we finished all that, we go back and we clean our welds, remove slag. This is all prior to painting. We also wire brush anything we need to clean up, and prime and paint the crane. Once we do that, it goes back to the fitting area. We install the hoist, trolley, festooning, wire it. This is all after painting. And then we get ready to do a no-load test, and we record this in our QA report. Lastly, we go over it again for quality welds, make sure we're square, and make sure we're all in compliance with what we're supposed to do as far as gauge. We don't have anything that's changed in this process. We check everything one more time. It goes on the Q&A report, and then we get ready to ship the crane. So I'm going to have to give some kudos here. We do everything by ANSI and ASME. We're all engineered here. We have been members of CMAA for since maybe early 2000s. And right now, our senior vice president of engineering, I guess she's a senior engineer. I don't know if we have a VP of engineering here, but she is the president of CMA presently, and she'll be the president next year as well. So Molly Wood is our senior engineer, and she's been here a long time, and her engineering team does a great job of keeping us out of trouble, I can promise you. All right. Let's go through. We're almost done here. I really appreciate everybody, and the questions are great. So just a few examples here. This is a picture we saw earlier. You can see the multiple cranes, multiple single girder cranes. These are top running with under running hoist on them. Here is an example of an under running hoist for a single girder crane. The top one here shows a box girder with a walkway on it, and you can see the bogie in truck. That question came up earlier. The bogie in truck is right there. You can also see, I erased this off here so you can see. Oh, shoot. You can see here that the bogie this is obviously a crane that's going to an area that has not much overhead clearance. So we've used a bogie in truck one, which lowers the over rail elevation, lowers the envelope. Excuse me, I couldn't think there. So bogies are typically smaller wheels, and it lowers the crane just because it's smaller wheels. Then they've coped this thing down a great bit, so it's actually going to be way down below the top of rail. You can see the difference there. So this is going into an area that's going to have a really small height over top of rail. And you see this is the same way here. You see the cope. They've coped it down real far here. And there's your in truck right there. Okay. One thing that, okay, never mind. And lastly, here we have a picture of a job we did in a dam. And this is a water weight test. I believe that was a 25-ton crane, but the water weight test there, this thing this was a really neat project here. So anyway, there's some examples of cranes for you. Leslie, we're going to sum it up a little bit, have some takeaways. You got overhead cranes, jib cranes, gantry cranes, monorails, workstation cranes. Depends on what you need, and and we can do any of those. Again, it depends on what your requirements are. Every crane is built by core components: bridge, trolley, hoist controls, in trucks, and any type of anti-collision or whatever we need to put on there, or radio, etc. Precision matters. Obviously, we built everything to 1/8 inch to be within tolerance. We don't do anything outside of CMA, ANSI, or ASME because, quite frankly, Molly's the president of CMA. Again, we ensure alignment. Good alignment reduces wheel wear and skewing. I've been here 25 years at ACE, and to my knowledge, we've not replaced a set of wheels on a crane that we built in the 25 years. So our cranes are squared, and we build it's a well-built crane. We like to cope the girder around the end truck, as I showed y'all earlier. It creates a stronger connection. It reduces stress on the crane, on the end truck, and the connection. And also it really helps prevent pivoting, which would be the crane and end truck doing this, or fatigue, which would be doing this. So we like to use a cope connection. A lot of crane companies like to set the girder on top of the end truck without a cope. We don't like to do that. So we spend a little extra time and make a connection that we believe is a better connection. Service classification, we talked to the CMA duties. We talked A, B, C, D, E, and F. It's basically light duty to severe duty. We determine what that is, and so we can get you the right hoist or the right crane that won't break on you on day 2 because you're overusing the crane. And lastly, we do the engineering, we manufacture. We have distribution offices in Houston, a little bit in Cincinnati, as well as Norcross. And we have service from coast to coast. And obviously, we've been in business a long time, so we like our customers here. Question here. For California customers have to adhere to California OSHA quadrennial load testing standards. You provide initial load test option at the manufacturing plant. The answer is no to that because we don't have enough elevation to do a load test at the plant. So we cannot do that. We cannot load test within the plant. And also we don't have enough concrete to put that much weight on it. Is all your welding done by certified welders, just inspected by a certified welding inspector? All of our welders are certified. Good question. Are all of your welders certified? Yes. And all of our welds are inspected by a certified welding inspector. So yes, the answer is yes to both of that. Good. That's a great question right there. So yes, everyone's certified. We hire an outside company to come in and certify our welders, just FYI. It works out better that way. So that's what's going on with that. So if anybody got any more questions, I'll turn it back over to Emily. And thank you guys. If you need to get a hold of me or us, you can reach us at sales@industries.com. You can email me if you have any good questions that I can help you with, any kind of application you want. Send it to agurley@aceindustries.com. And of course, we always have our website, aceindustries.com/cranes. So we'll be glad to help you out.
We have 2 more questions in the chat right now.
Okay, I got one here. Do you set up temporary runway on the floor of your shop for factory acceptance test of the crane? We would have to put it on floor jacks to do that. Yes, the answer is yes. Or you have to put it on floor jacks. We'd have to put it on floor jacks to do that. Good question.
Someone else asked, how long until you get the Illinois location up and running?
I don't know where the Illinois location is. We got a location in Detroit and we got a location in Cincinnati. So those guys, and we got a location in Lexington, Kentucky, or Louisville, Kentucky, I think. So we could probably get to Illinois if we need to. Depends on how many cranes you got.
Someone asked, do you manufacture gantry cranes?
No, we do not. We manufacture semi-gantry cranes. We do not build gantry cranes. We could build smaller ones, but typically people want 20, 30, 40, 50 ton gantry cranes, and we don't have the capacity to be able to do that. Good questions, though. Great questions. That's all I got, Emily. It's all on you now.
All right. Also, there's talk in the chat. There's already work in Illinois. So, all right. Well, I'd like to thank everyone so much for joining us for this webinar, and thank you to Andy for all the work that he's done in putting this together, and we really hope that you guys enjoyed. We will be sending out a recording of this once we have it complete, and it will be sent to your emails, whatever one you registered with. So look out for that. And again, thank you so much, and we look forward to seeing you in the next one.
Thank you.